Aldehydes are a homologous series of organic materials that contain the functional group CHO. If we were to draw this out in full to show what the functional group would look like, it would be a carbon double bonded to an oxygen, single bonded to a hydrogen. For the nomenclature of these molecules, we simply end our molecule with al. For example, this molecule has 3 carbons. It has the aldehyde functional group on the end, and therefore would be called propanal. It's important to notice that the functional group can only be on the end carbon. Therefore, that's always classed as carbon 1 when we're drawing other molecules that have side chains that we need to number. Here's another example. In this example, we also have a bromo group on carbon 3, simply because the aldehyde group has to start on carbon 1. So if we were to name this molecule, we're going to end up with the name 3-bromo-butanal. We don't have to number where the aldehyde group is, it's always on carbon 1. If we take another molecule that also contains a functional group that may usually be the ending of a molecule, such as an alcohol, we can see that we can name the alcohol part in a different way. In this molecule, because the aldehyde group takes part of the main chain, we now need to number the alcohol group, but we cannot call it an alcohol as in the ol ending. We now need to call it a hydroxy. Therefore, in this molecule, we have 3-hydroxy propanal. Notice that the aldehyde group once again is carbon 1, therefore the alcohol group has to be named on carbon 3. Preparation of aldehydes comes from the oxidation of primary alcohols. During this process, the aldehyde has to be stilled away as it's being formed, otherwise further oxidation of the aldehyde can occur, which would make a carboxylic acid. The general equation of oxidations of alcohols to carboxylic acids, we can show ROH, R being the alkyl chain, so that's any length of carbon chain with an alcohol group attached, going to make our aldehyde. And we can put an O in square brackets above the equation. Now realistically, we have to show this as a full redox equation, as it's normally oxidized by materials such as potassium permanganate or sodium dichromate. So simply for a half equation for oxidizing an alcohol to an aldehyde, let's take ethanol becoming ethanal. But once again, we leave the gap so we can add on as we balance our equation. So if you remember, the rule is you add water to the side that's deficient of oxygen. Well, in our equation, there is no balancing needed for the oxygens, therefore we don't need to add water. We add hydrogens to the side that it's deficient of hydrogens. So if you look on the left hand side, there are 3, 4, 5, 6 hydrogens, and on the right there are 4. So we need to add 2 hydrogen ions. We then balance with electrons to show that our charges are equal. Therefore on this side we will need to add 2 electrons, and that's the half equation for ethanol becoming ethanal. This can then be used with another half equation such as the one for permanganate or for dichromate, and then balance to form a whole reaction. For example, with the permanganate equation, so when we add these two equations together, we will be multiplying the top equation by 5 and the bottom equation by 2 to give a full overall equation of, now you'll notice in this equation that we have got hydrogen ions on both sides. Therefore we need to remove 10 hydrogen ions from both sides in order to simplify the equation. So we can do that quite easily. And there you would have the overall redox equation for the reaction between a primary alcohol, ethanol, and the permanganate ion in order to form ethanal. The observations for this would be that the colour change goes from a pink purple to a pale pink colour. If we take a look at the properties of aldehydes, first of all we can see with the carbon double oxygen bond that we have a delta positive carbon and a delta negative oxygen. This means to say that overall the molecule is polar. Therefore it will have dipole-dipole forces between molecules. Because they're stronger than the dispersion forces between all molecules, it's going to have a high melting point and a high boiling point in comparison with other molecules of its size.